Can you imagine during your lifetime publishing a work that amounted to 18 volumes and 12,000 pages? A work that has been described as standing alongside the great encyclopedias and dictionaries ever published, and has been regarded as a monument to the power of human understanding. This is the accomplishment of Joseph Needham, whose Science and Civilization in China, the first volume of which was published in 1954 and which is still being published today, brought a ground shift in Western understanding of Chinese achievements in science. Needham was a Cambridge biologist who originally went to China in 1943 to investigate the university system in China, which it was thought had fallen into disarray during the war with Japan. Needham's investigations led him to realise that China, far from being a place where the only goods that Westerners might want were silk, porcelain and tea, in fact had a history of technological achievement that surpassed that of the West. And he made it his life's work to document that past history of technological achievement. Needham found that many of the great inventions of the West, gunpowder, printing and the compass, arched bridges, crossbows and the stirrup, blast furnaces for producing iron, had been invented in China long before they'd been invented in the West. Here's one example from Needham's work. It's a formula for gunpowder, which dates back to the 11th century. And you might remember in an earlier section of this lecture I talked about the invention of gunpowder in the West in the 15th century. So 300 to 400 years earlier in China, a formula for gunpowder than the West. Here's another example. So the large boat at the back is a model replica of Admiral Zheng He's flagship from around the 1430s. The small ship at the front is Columbus's Santa Maria. Now, there's some dispute about the extent to which the model of Zheng He's flagship is perhaps larger than those boats at the time would have been, but it's still the case that it seems that China had a significant advantage in naval technology, shipping and navigation over Europe at around the time that Zheng He and Columbus would have been sailing. We now realise that in the first 500 years of the last millennium, China was a highly advanced, by the standards of the time, economy. This is something that's summarised by Justin Lin in this quote. In short, China by the 14th century was probably the most cosmopolitan, technologically advanced and economically powerful civilization in the world. China had a brilliant start and remained creative for several thousand years. We know that in this period China was highly productive as an agricultural producer because rice could be grown as a main crop. It meant that capital requirements were relatively low. China had made major developments in wet soil farming technology, and as well the importing of champa rice from Indonesia opened up the possibility of cropping the same land twice during each year. We also know that China was advanced technologically as an industrial producer, for example, producing much larger amounts of iron than Europe did in this period. And China was also relatively urbanised and also had relatively advanced commercial systems for the time. One of the questions that's debated amongst economic historians is how long it remained the case that China was ahead of or on a par with leading nations in Europe. A group called the California School have argued that this was probably the case up until the 17th or 18th century. Other economic historians have disputed this, arguing that it's more likely that China fell behind Europe after the 16th or 17th century. So here's one example of research which looked at the daily wage of unskilled farm labourers in the Yangtze Delta in China compared to the English wage for an unskilled worker. Measured two ways, sort of using silver as a way of creating a comparable measure of wages, or using the amount of grain that could be afforded per day as a way of creating comparable measure. You see that 1550 to 1649, at least on the grain measure, workers in China were comparable to workers in Europe, not so much with the silver wage, but whichever measure you use, by 1750 to 1849, China has fallen behind England. The same finding emerges if you look at wages within city regions in England and China. It seems that by the 18th century, the wage of urban workers in areas like Beijing was lower than the wage, well below the wage of urban workers in, for example, London. However, it does seem that wages in China remained on a par with other lower wage European areas, with also areas such as India and Japan. It's also important to remember that in the period from 1600 to 1860, there was a very large increase in population in China, from 160 million to 380 million. So it certainly seems to be the case, when you take into account the population growth and when you look at the wage numbers, that by comparison with much of the rest of the world, China remained a relatively advanced economy up until the 17th or 18th century. But it had certainly fallen behind the leading nations such as England and the Netherlands by around about the 17th, 18th century. The fact that China was an advanced nation, was a relatively rich nation, has raised the question of why didn't the Industrial Revolution happen in China? If China was ahead of Europe in its technological development in the first 500 years of the past millennia, if it remained by general European standards a relatively rich economy up until fairly recent time, then one question to ask is, why didn't the Industrial Revolution happen in China? There's been a variety of explanations suggested for that. One explanation is the idea that differences in resource availability between England and China explain why the Industrial Revolution happened in England rather than China. So the argument goes that both England and China faced declining availability of wood for fuel and limits on land for growing food and raw materials, what's sometimes referred to as an environmental constraint on growth. The argument is that England was able to relax those environmental constraints. It turned out England had coal, which could be used as a source of fuel, and through its expansion of international trade and conquest, for example, with the New World, it was able to gain access to food and raw materials from other parts of the world that relaxed the constraint that existed on growing more food or obtaining sort of more raw cotton from within England. Now, there have been a variety of criticisms of this explanation. There have been arguments that, for example, England didn't face an environmental constraint of the type that this argument suggests, and it's also asked, well, it may be that limits on coal and some food raw materials limited some types of technological innovation, but it shouldn't necessarily have limited all types of technological innovation in the way that seems to have occurred in China. So a second explanation is more generally about the idea of an attitude towards invention. It's the idea which we've talked about in the last section of the lecture to do with why the Industrial Revolution happened, that perhaps China didn't have an industrial enlightenment, that there was never the orientation towards experiment as a way of doing science that happened in England. This is an argument that's been made by Justin Lin. He makes the argument that in pre-modern times, technological innovation mainly came about through experience. And experience, when experience is the main driver of the amount of invention, then the main thing that's going to determine the amount of invention that happens is population size. A bigger population means you've got more people having a variety of experiences. That means they learn more. So China was a country with a large population, and so Lin argues that that's consistent with the idea that China was relatively innovative in the first 500 years or so of the past millennium. But then, as we've seen in the case of England, science came to be based on experiment. And experiment isn't about population size. Experiment is about the attitude that you have, the approach you have to doing science. Because one person can do a large number of experiments, population is no longer a constraint on the amount of knowledge that can be gained. Now, it's been suggested in a variety of contexts that population size could be a driver through, for example, experience of the amount of technological change that's occurred. Here, I've taken some data on the number of innovations in science and technology in China by century. And you can see the sort of idea that up to sort of the 1600s, a large number of inventions in science technology, but then dropping away in the 1700s and 1800s. One problem with this pattern in terms of the idea that science derives from experience in population size is that it's actually sort of the 1600s to the 1800s where there was large increase in population in China. So there may be some issues about the argument that the initial innovativeness in China was to do with population size. Nevertheless, that doesn't mean that we can't think of the reason there wasn't an industrial revolution in China as being to do with the idea that there was an absence of an industrial enlightenment, the absence of an experimental approach to doing science. And there's been a variety of explanations proposed for why science might not, why in China there might not have been this change in orientation towards experiment-based science. One is the idea that China was a unitary state, whereas Europe consisted of a whole lot of states. And in particular in the Ming and Manchu empires, there was a strong state control of what happened in society. And it's argued that that means that if an idea, an approach is opposed by one person, one group in society, it can be knocked out. Whereas in Europe, with a whole lot of competing states, if an idea or approach wasn't liked in one part of Europe, there was always another state in Europe to which, you know, scientists, inventors could move where they were possibly would gain support in doing their science and doing their invention. Another argument is the idea that China had an incentive system that drew its most talented members of society to working in the bureaucracy. So rather, as in England, sort of, where in the last section of the lecture I talked about an attitude that valued industry, that valued entrepreneurship, in China it's been argued there was a culture that primarily, for at least the most talented members of society, valued working in the bureaucracy. Third argument is that there was a lack of institutions in China that allowed for cumulative learning in the way that occurred in England and Europe. And another idea proposed is that in China there was a high preference for avoiding social dislocation. So we know that introducing new technologies in England, in Europe, was opposed by workers in industries who were being displaced by the new technologies. In places like England, that dislocation could be contained, but it may be that in China there was a fear of the social dislocation that would come from that type of technological innovation. Also need to ask, in thinking about sort of why China didn't have an experimental approach to science, why it didn't learn that approach from outside. So there's the letter from the Qianlong Emperor to George III of England rejecting his request for trading rights and a permanent legation in Beijing, that we have never set much store on strange and ingenious objects, nor do we need any more of your country's manufactures. And so this has sometimes been suggested to say that China had an inward-looking approach at the time, an approach that turned it away from valuing activities that the rest of the world was doing in a way that may have meant that it didn't take up on experimental science. There's a variety of other explanations that have been proposed. The idea that within China, trust was mainly within kinship groups, whereas in Europe, the commercial city meant that trust ended up being extended across larger groups, and that the more restricted basis of trust in China has been an impediment to economic activity in the long run, and the sort of incentives that creates for invention. Another explanation is that markets were more integrated in England than in China at around the time of the Industrial Revolution, although they weren't more integrated in China. They weren't less integrated in China than the rest of Europe. There's ideas that the state played a stronger role in promoting technological innovation, in providing social infrastructure that could underpin economic activity in England than China. And there's also the idea that there was a lack of horses for courses, that it was in England that there was the high price of labour and the cheap energy, and tying into what we discussed in the last part of the lecture about that as a potential incentive on a potential determinant of what to invent, that because China lacked that particular combination of prices of inputs, that was what meant that it wasn't directed towards invention in the same way as happened in England. So there's a large variety of explanations for why the Industrial Revolution didn't happen in China. It's an immensely interesting question when you recognise how technologically advanced China was in the first part of the millennium, and how relatively advanced they remained up until a fairly recent time. The historical evidence we have available probably doesn't mean that we're able to distinguish at the moment between these explanations as much as we'd like. My personal view is that the ideas based around the absence of an experimental science-based approach in China seem to be important, but why there was that absence is more difficult to explain, or at least at the moment we don't have a good basis for distinguishing between the reasons that I suggested for why there might have been that absence. In the next section of this lecture, I'm going to go on to talk about what contemporaries in England thought about the Industrial Revolution that was happening in their country.